Now, now I will start the 3D meshing. See here, one thing I want to tell you here: the YouTube videos which I have uploaded, content of that videos I have skipped. You can watch that video and you can learn from that videos also. And the whatever things I am teaching, that may be somewhat different. I am taking that also, and other than that also I am taking some extra things. Okay. Now we'll start the 3D meshing. This is your next experiment, 3D meshing. Now 3D meshing, here these are the 3D elements. Okay, and actually it is 3D body, and this is the explanation for use of 3D elements. When to use the 3D elements? Already I have told you, when we have all three dimensions are comparable, that means this x, y, y and z, all these three dimensions are comparable, then you have to go for 3D meshing. Okay, 3D meshing or 3D elements. Do you agree with this? Here, in first one dimensional elements, for one dimensional element, if we have only one dimension, mute करा. जर बॅकग्राऊंड साऊंड जास्त असेल तर म्यूट करा कोणाला. Okay. Now, if all three dimensions are comparable, then you have to use 3D elements. If only one dimension is comparable, or if it is a big, then we have, if two dimensions are big and third dimension is very small, then you have to go for two dimensional. I think you can understand this concept. Now here element shapes are tetra, penta, hex and pyramid. That means tetrahedron, pentahedron, hexahedron and pyramid. These are the shapes of the elements. That means tetrahedron means here we have 4 nodes. Pentahedron means 5 nodes. Hexahedron, this type of shape is hexahedron. Pyramid, okay. Here two triangles, when we join two triangles, it may become pyramid, okay. Or we can say one base of quadrilateral chord and corner, you will get pyramid. Now here we are giving all three dimensions. Therefore we don't require any user data. That means software doesn't require any user data, okay, because we are providing all dimensions. Are you getting this? That means we have three by additional data required from user, it is nothing, okay. In case of one dimensional it is area, and in case of two dimensional it is a thickness, okay. Here element type is solid. You can see here this is the element type as a solid. In case of one dimensional, element type is line. In case of two dimensional, element type is plane, and in case of three dimensional, element type is solid. These are the practical applications of the three dimensional elements, that is gearbox, engine block, crankshaft, okay. These are the practical applications. Next one, you can see here these are the shapes of the elements, 3D elements. Now this is a tetra element. It is a linear tetra having 4 nodes. This is a parabolic tetra, that is a higher order tetra element having 10 nodes. This is a penta element having 6 nodes. Here this is a parabolic penta or higher order penta element having 15 nodes. This is a hex element, or it is a hexahedron element, or it is also known as a brick element. And this element what we can say, this element is a very useful element, or it is going to give very accurate results as compared to other elements. Okay, this is a hexadron element. This is a parabolic hexadron element, that is higher order hexadron element, that, and it has some mid nodes, that is nodes at midpoints of these edges. Okay, and here we have corner nodes only. This is a pyramid element. Here base is chord and one apex is there. Okay, this is a linear pyramid element and this is a parabolic pyramid element. Okay, and in parabolic pyramid element, that means it is a quadratic pyramid element. Here if you relate the theory with this, here there are linear polynomials, these are linear polynomials, and these are the quadratic polynomials. All these elements are having quadratic polynomials. Okay, now here degrees of freedom for solid elements. Okay, now in case of 2D thin shell and 1D beam elements, there are 6 degrees of freedom. That means these elements are supporting to the 6 degrees of freedom, but these solid elements are only 3 translational degrees of freedom. 3 translational degrees of freedom. Now this may be your interview question: why solid elements are not supporting to the rotational degrees of freedom? Rotational means what happens when we bend any component, we will get the rotations about the axis. Am I right? But if you bend the 3D element, 3D element, it will not bend. Why? Because of its dimensions. Bear with this. Here bending degree of freedom is not in case of 3D element. It has no rotational, because there we cannot bend the 3D element. Our bending force is very high for 3D elements. Bear with this, and it is considered as infinite force, so it is not going to support the rotational degrees of freedom. Okay, now if you consider this one dimensional element, we can bend these images, we can bend. Here this is one dimensional, we can bend. That means if we consider the steel rule, or if you consider the repeal, if you consider the push rod, that we can bend. Okay, now if you consider this two-dimensional geometry, it is or sheet metal components, that also we can bend. But when we consider a small brick or small small block, that means having small dimensions, that we cannot bend, so we will not get the bending degree of freedom or rotational degree of freedom for three-dimensional element. Okay, now these are the quality criteria for elements. Here quality check for tetra element. Here ideal value is 1, and acceptable value is should be greater than 0.1. That means 0.1 is the quality criteria for tet element. Now what is the tet collapse? See here, in case of tetra elements, we are checking the tet collapse. Other parameters we are not checking. Okay, now tet collapse or tetra collapse is the height of the tetra element into 1.24 divided by area of the element. Okay, area of the face. Okay, now see here if your height is very small, that means if your tetra element is flat, then it is considered as a failed element in the tet collapse. Are you getting this? That means it is a collapsible tetra. Agree with this, and this we are considering as a tet collapse. Now next is a volumetric skew. Skew, it should be less than 0.7. Okay, it is ideal volume of the element minus actual volume divided by ideal volume. Ideal volume of the tetra element means what? Here when we draw the triangle, sphere passing through all the corners, the tetra element having equilateral triangle, then that volume is considered as a ideal volume. Okay, now actual tetra, because of the geometry we cannot get all equilateral triangles. Okay, it may have equilateral triangle, or it may have triangles having different sizes. Okay, so you will get the actual volume different than the ideal volume, so we'll get the volumetric skew. Here, if it is acceptable in Tate collapse, it will be acceptable in volumetric skew also. Next is a stretch. You can see this and you can read this all the things. Here Jacobian is 0.5, ideal value is 1, distortion. Okay. Now see here, these are the quality criteria for elements. Here in this experiment, what we are doing, we are, or I will explain how to create the solid in the hypermesh, how we can edit the solid model. See here, creating the solid, I will not explain all the things in detail because it is not task of the hyperverse, but sometimes we need to do the now how we can edit the solid. Editing the solid is required in hypermesh, similar to the editing the 2D geometry. Okay, I will explain how to edit the solid in hypermesh. Okay, and that editing is required for getting good quality mesh. Okay, next I will explain the tetra mesh. Now I will give one exercise on tetra mesh. Next I will show you how to create the hex pentamesh. Okay, and then I will show you how to create the hexahedral mesh. Okay, these are all the things I will explain, and it requires 3 to 4 practicals, and I will give that 3 to 4 practicals for doing all the things. Okay, now I will start with the and editing the slides. Okay, now for that purpose I will open the hypermesh. Now I will open one model, that is a solid model geometry. I have opened this geometry. Now you can check whether this geometry is surface geometry or solid geometry. You can see here. Okay, now see here, it is a surface geometry. Why it is surface geometry? If you make it in line mode, if you make it in line mode, you can see here, you can see here, this is in line mode. Now if you observe the lines, these lines, these are very thin lines, so it is a solid, not solid geometry, it is a surface geometry. Are you getting this? Now how to convert this surface geometry to the solid geometry, that also I will show you. Okay, now for converting the surface geometry to the solid geometry, you go to the geometry. Now click on solids, click on solids. Now here there are different options to create the solids. These options are same to the modeling softwares. These I will not explain all these options. Okay, here first you have to create the box, then you have to create the cylinder, and that cylinder is full cylinder, partial cylinder. This is a cone, that is a full cone, partial cone, sphere, full sphere, partial sphere. Next it is a torus. Okay, next this is a bonding surface. I will explain this bonding surface. This one is spin, that means it is same to the rib option in the modeling software. Next this is the drag along the vector, that means it is a extrude option, and this is a ruled option. Okay, now I will explain how to convert the surface geometry to the solid geometry. Now for that purpose you go to the this option, that is bonding surface. It is a sixth option. Now click on bonding surface, click on bonding surface. Now I will make it in surface mode. Again you can see here, one more thing I want to tell you, it is a surface. How you can check it is surface, whether it is surface or solid? You mask any one of the surface. I will mask this surface. You can see here, you see here, this is a hollow inside. Do you agree with this? This is hollow inside. You can mask any surface. You can see here. This is hollow inside. Now if I mask this one, see here. This is the hollow inside. Means it is a surface geometry. It is not solid geometry. Okay. I will unmask all. Now if it is a closed geometry, then we can convert that into solid directly. How we can do it? Go to the solids. In solid, there is a bonding surfaces option. Select the bonding surface option, and if it is a closed surface geometry, then you can select all surfaces at a time. Okay, you can select all surfaces at a time. These surfaces are selected. You can see here. If it is not closed geometry, if I do it, that means if there is a gap in the geometry, I will toggle one line and I will show you. See here, there is a gap in the geometry. Okay, means there is a free edge at this location. If there is a free edge at this location, you can get in topology also. You can see here. Here there is a free edge. Okay, if there is a free edge in the geometry, then we cannot create the solid geometry from it. Now you can see here. I am in the same option, that is bonding surfaces. Select this one. It will not select. Okay, it will not select. You can see here it will select only single and it will not select in proper way. Why? Because it is not closed surface. So that you have to remove this, or you convert this red line to the green line. Means you have to convert that free edge to the shared edge. Okay, how you can do this? You select the toggle edge, you enter here tolerance value and click on this line. Now it is converted. Okay, now I will create the solid of this. Go to this one, select this surface and say create. Now you can see here, I will return from here. Okay, now I will make it auto. Now you can see here, if you observe these edges, I will change this color. If you observe these edges are bold edges. Have you got the difference? Yes. Kunal Patil, have you got the difference? Solid and surface.
Yes, sir.
Okay. Now see here, I have used the bonding surfaces option and I have converted that to the solid from the surfaces, close the surfaces. Okay. Now I will show you one more option, that is how to create the cylinder. You can see here, and same approach you have to use for all other components. Now I want to create the cylinder here at this location. Now select the cylinder. Now select the bottom center. Suppose this node is at the bottom center, and select the normal vector, means it is the axis of the cylinder. Normal vector, it is this bottom center to this node. That means this node to this node, it is the axis of the cylinder. Now you enter the radius. Base radius means it is the radius of the cylinder. Suppose I am going to enter as a 4 millimeter. Okay, and I am going to enter here 20 millimeter as a height. 20 millimeter as the height. And if I click on create, that cylinder is created at this location. You can see it in wireframe mode. You can see here it is in wireframe mode. Now this cylinder is created here. Okay, these are the two solids here. This solid is on the original first solid. Okay, now I will make it in this mode again. Now you can see here you will get the one more cylinder. Initially it was only node. Okay, now I will show you how to edit the solids. Now I will go to the solid edit. Okay, first what I am going to do, I am going to remove this cylinder from this solid. Okay, now for that purpose, there is a Boolean operation. You have learned Boolean operations in the modeling softwares also. Okay, and here also you will get the same purpose of that Boolean operations. Now go to Boolean operations. what I want to do, if you want to add this cylinder to this one, then you select the A plus B, operation A plus B, that is union operation. Now if you want the intersection of these two solids, you select the A into B, that is A star B. If you want to remove the B from the A, then you select this one. Okay, now I want to remove the B from A, I will select this one. Okay, that is, these are the Boolean operations: A plus B, A star B, A minus B, A minus B, B, that is cut A with B. Okay, you can learn by reading also this. Okay, now what I want to do, I want to remove the B from the A. Now which is a B? B is this cylinder, and A is what? A is this complete solid. Okay, now I have to select the A, which is a solid. A solid, I am going to select this as a solid. Okay, now next one, B solid, which is a B solid. B solid is cylinder. Okay, now see here, this is a B solid. Over and click on calculate. Now you can see here, you will get the cylindrical hole at this location. I will remove the temporary nodes. Okay, you can see here, you will get the cylindrical hole at this location. Why? Because we have removed this cylinder from cylindrical solid, we have removed from this complete solid. Okay, now this is one operation, that is a Boolean operation. Okay, remaining operations also I am going to show you. Now see here, these operations are very important operations, that is trim with the nodes, trim with the lines, trim with the plane surface. Okay, and merge also. Okay, now these operations, why these operations are required? See here, it is these are similar to the splitting of the surfaces. We have used the split surfaces. Here we are using the split solids. Okay, that is trim with the nodes means splitting the solid with the nodes. Okay, now first I will go to the trim with the nodes. Now for splitting the solid by the nodes or trimming the solid by the nodes, we need at least 3 nodes. Okay, and that solid will be trimmed, by passing the plane through that 3 nodes. How we can do this, I will show you. Now suppose I want to trim this solid by passing the plane through this corner, and this corner. Okay, agree with this. Now I will select this one. Now I will select the 3 nodes. We need to select at least 3 nodes. You can see here, I will select this node. Here I am going to select one node. It is not at the proper position at this, sorry, here. Okay, second node I am going to select here. See here, just what you have to do, you click on that line, then you can select, just click on that line and press and hold the left mouse button, then that line will be selected, and you can see here, and you select the end of the line. Now node, I have selected these 3 nodes. I will show you again how to select these nodes. See here, I want to select this node. Either I have to select this line, that means click and press and hold the left mouse button on this line. You can see here. Okay, after that, that line will be selected. Then I want to select this node. I have to click on this node. Okay, we agree with this. Now I want to select this node. Either I have to select this line or I have to select this line. I will select this line. Okay, and I will select this node. Okay, now this node, for this node I will select this line and I will click at this location. Here, this is the first node, this is the second node, and this is the third node. What will software, what software will do? Software will create a plane passing through these nodes. Okay, and that plane is acting as a cutting plane to the solid. Okay, now you can see here, I will click on trim. You can see here this red colored plane is created at this location, and that plane is acting as a cutting plane. That plane is acting as a cutting plane. Now this is a triangular plane. Okay. Now if you want to, I will reject this. If you want to, what we can say, if you want to trim the area coming in that, or if you want to extend the cutting plane, extend means whatever is already coming in that plane. Do you agree with this? That means if we consider the plane, plane is infinite entity, infinite entity. If you want to cut the all the things, whatever coming in the path of that plane, that also possible. How we can do this, I will show you. You can see here. You see this one. Now I will select this solid again. Again, I am going to select these planes. Now I will go to the nodes. I will select this line, this node. I will select this line, this node, this line, and this node. Now there is one option, extend trimmer. Extend trimmer means you have to extend the cutting plane. Okay. Last time it was only for this portion. When we extend, it will move to infinite. That means anything coming in the path of that plane, that will be cut by that plane. Okay. Now I will select extend trimmer and click on trim. You can see here any last time it was this plane, but because of extend trimmer, that plane is extended in this direction, and and that solid which is coming in the path of that plane, that will be splitted into two parts, that will be cut or trimmed by that plane. Okay. Have you got this concept? Have you got this concept? Pranjal Shelar?
Yes, sir.
Okay. Now next one, see here, this is this plane has trimmed solid, means it is converted into number of solids. Okay. How we can get it, I will show you. Now next one. Now if I select the solid, if I select this solid, it will be different solid. Okay. If I select this solid, it will be different solid. Okay. If I select this solid, it will be different solid. Why? Because we have trimmed that solid, we have splitted that solid, we have cut that solid by that cutting plane. Okay. Now if you want to merge it, how you can merge it, I will show you. Again, you go to the geometry, solid edit, select the merge option, merge solid. Okay. Now if you want to merge this one and this one, okay, that will be merged here. You can see that cutting plane will be removed from here. Now if you select this solid, that will be continuous solid. If you want to merge this with this, you can select this also and same merge. Now that solid is combined. It is known as a combining of the solid. Okay. Now next option, it is a trim with the lines. Trim with the lines. Here, trim with the lines. Now there are different options for trim with the lines. You can see here. Here, this I will not go for this one. It requires more time and it requires cutting line. Okay. Now I will, and this is, we are not using this option. We are using this option. Okay. now here, with bonding line, trim with bonding line. Okay. Now what I will do, here there is one bonding line, you can see here, trim with bonding line. Now I will select this solid. Now here, while using this option, that line should be bonding line. Bonding line means it should be continuous around the solid. That means you can observe this line, these lines. Here, these are the 4 lines, and that solid is bonded by these 4 lines. Do you agree with this? If your bonding line is like this, then we can do it. If your bonding line is not continuous means like this. You can see here. This line is up to here, but there is no line from here to here. Okay, there is no line from here to here. In this situation, we cannot use this option. That is a bonding line option. Okay, so here your solid should be bonded by that lines. Again, this line, if you observe this line is only on this surface. It is not on this surface. Here also you have line, but there is no connecting line at this location. That means this solid is not bonded by these lines. Okay, do you agree with this? So here complete bonding should be there, otherwise this option will not work. Okay, do you agree with this? Now I will use for other type of lines, there are different other options. I will show that options also. Now here select the solid lines. Now I will select this bonding line. You can see here, just click on, sorry, this is, I will deselect this. I will select this line, this line, this line, and this line. Okay, now after selecting all these lines, and if you click on trim, you can see here that will be cut here. Now here also there is a no extend trimmer active. If we select the extend trimmer active, that will be extended here. Okay, you can see here, I will reject it and I will show you again. Now last time which I have shown, it is not extend trimmer. If I select the extend trimmer, I will select this solid trimming lines, I will select this line, this line, this line, this line, and if I select this extend trimmer, it will be extend here, it is extended here. You can see here, this plane is extended here, and this solid is trimmed at this location also. You can see this one, this plane is continue up to the end of the solid. I got it, it is a extend trimmer. Now I will merge again. I got this second option, solid with bonding line. See here, you cannot use this option for this type of lines. You can see here, if I select this line and this line, it will not trim. Sorry, it has trimmed because the extend trimmer is there. Okay, I will reject it. Now next one I will merge this. Next one, again I will go to the solid edit, trim with the lines. See here, we can extrude the line. That means we can use single line for trimming the solids. How we can do this? That means we can extrude the line as a cutting plane. How we can do this, I will show you. Now see here, I want to extrude complete solid from here to here by using this single line. How I can do this? I will set this solid lines, this line. Okay, now here you sweep the line and make a cutting plane. Okay, sweep the line, that means extrude the line and make a cutting plane. Now in which direction you want to sweep the line, then you will get the appropriate cut. Now you can see here, that will be in x direction. You can see this, observe this, that will be in x direction. Now you click on this arrow and select the x-axis. Okay, select the x-axis and select the sweep all, then it will sweep the complete solid. You can see here, now you can see here that line is extruded in this direction and it will cut the solid. You can use any line, you can see here. If I use this line, I will merge this again. Now if I use this line, you can see this one, trim with the lines, solids, this one. If I select this line, now in this situation, it is in z direction. Okay, now you select the z direction. Okay, now you can see here, this line, it will move in the z direction, and if I click trim, you can see here, this plane will be created in z direction. Okay, do you agree with this? Now I will merge again, this one, merge. Okay, have you got this? This option, this is also important option. We need to trim with the solids, these two options, by bonding line and by trim with planes and surfaces. Now I will show you first by surfaces and then I will show you by planes. Now I will select this one, trim with the surfaces. You can trim with the surface. You can see here, if I want to trim with this surface, it is a curved surface. Then I will go to the surface, this surface, and say trim. You can see here this will be trimmed at this location. You can see anywhere solid. If I select this solid and if I want to trim with this surface, and you have extend trimmer active, okay, so it will extend. You can see here this is trimmed at this location. Do you agree with this? Have you got this? Have you got this? Kunal Patil, have you got this? If you have doubt, you can ask me. Pranjal Selar,
Okay, sir.
Preeti Digare, Preeti Digare, Avanti Nalode,
No, sir. No doubt.
Sarvesh Chevde.
No doubt, sir.
See here, it is simple operations. Just you have to do the practice of this, then you will get the idea of this one. Okay. Now next is also important. I will show you. Now I will go to the solid edit. See here, I will merge this. See here, if you want to split the solid into two parts by surface, then you have to use split by surfaces. Okay. Now I will merge it. And depending upon the situation, you have to use the appropriate option. Okay. Now, next one, trim with the plane. Trim with the plane. How you can do this? See here, if you have already plane, then you can trim with the plane, or if you don't have plane, then also you can do it. How I can do this, I will show you. Now you can create the plane also. You can see this. I will go to the solid, this one. Now I will select the four nodes for creating the plane. Okay, actually it is three nodes over for creating the solid. Now I will show you how to do this. You can select the nodes from the lines also, or you can create the nodes also. I will show you. I will go to the geometry. I will create the nodes, and I will create the nodes on the lines. I will show you this line. Create. Okay, and this line again I will create. Okay, and that nodes should create the plane. It should not be linear nodes. All nodes should not be linear nodes. Okay, now I will go to the solid edit. I will select this solid here, this solid. You see this one, how I am going to select the nodes. You see here, I am going to select this node first, this node second, and this node third. That means it is going to create one plane. It is going to create one plane. Now where is the origin of that plane? Now for that purpose, I am going to take origin at this location. Okay, here, and I'm going to trim it. You can see here, it will trim by creating the plane passing through these three nodes. Okay, you can see again, I have created these three nodes. Sorry, I have created these 6 nodes on 2 lines. You can create 2 nodes also. Okay, 2 nodes also. You see this one. Okay, now I will select this solid, this. Now I am going to select this corner node, this as a second node, and this as a third node, and you can get the plane passing through these nodes. Okay, now you select the origin of that plane. I will select this as the origin of that plane. Okay, now click trim. Okay, now in this way also we can create the trim. Sorry, we can use the trim solid option. Okay, now I will return from here. Again I will merge it. Solid edit, merge this one, this one, this one. Okay, merge. Okay, have you got these options? Trim with the plane, trim with the plane. See here, if you want to create the nodes that are not already created by using lines, same thing which we have done for the trim with the nodes. Okay, it is same to the trim with the nodes. You can see here, solid, this one. Now I will create the node on this line. Just a drag on this line and you put here. Okay. Next here. Next on this line, select this line and put node here. Now origin here and trim. You can see here you will get that option. Okay, I got it. And you can create the lines also for splitting. You can see here. I will return from here. I will merge it. I will return from here. I can create the line here. How you can create? That is, here you have to create the split surface. Split surface. You can see here. Now I will select node here. This line. Okay. Now this line, and this line. So here I have created bonding line. Okay. Now I will go to the solid edit and I will select the trim with the lines and I will select the bonding line. I will select this solid trimming line, this one, this one, this one. Okay, and say trim. You have created the two parts. Have you got it? I will return from here. Now this is about the geometry editing, that is solid editing. Now I will go to the tetra mesh. Before that, if you have doubt in solid editing, and same video I have link of YouTube uploaded on your group. Okay, that means I have shared a link of YouTube video on group for 3D meshing. You can watch on that YouTube. Okay, now I will go to the new for tetra meshing. I will open the model. You see this, it has, this is a without mesh. Okay, this model I am going to show you for tetra meshing. Okay, if you have doubt you can ask me, otherwise I am going fast, and if you miss something then it will be difficult to submit the exercise. Okay, Pratibha. Okay, now I will show you tetra meshing. Now before that, you see here, this is the surface geometry again. Am I right? Why it is surface geometry? Because you see, you observe these lines. You observe these lines. You can change the color also. You observe these lines. These lines are thin lines. These are not bold lines. Okay. Over. Now you can see here, these lines are not bold lines, so it is a surface geometry. Again, you can mask any surface. If I mask this surface, you can see, okay, I will mask other surface which make it visible. I will mask this one. You can see here, here you will get the portion of the geometry which is inside the that surface. Okay, you can see here. Or you can see this one, these lines, because it is hollow. Now I will unmask all. Now next one, I want to mesh it by using tetra elements. See here, if it is a closed surface geometry, then you can use directed tetra mesh. You can mesh by tetra elements if you have closed surface geometries. Okay, if you have solid, that also possible to mesh by using tetra elements. Okay, Now I will go to the tetra mesh. For tetra mesh, you go to the 3D page. 3D page. Select the tetra elements, and these elements, see here, this way, if geometry is very complicated, then you have to go for tetra elements. Otherwise, you go for X elements, hexadron elements. Okay, because results of hexadron elements are accurate as compared to the tetra elements. Okay, now here it is on 3D mesh or 3D page. Create the tetra mesh. Okay, now here these first two options are for converting 2D mesh to the 3D mesh or remeshing the already meshed part. Okay, and if you have solid geometry or surface geometry, close the surface geometry, then you have to go for volume tetra mesh. Select the volume tetra. Okay, volume tetra. Now here, if you are solid, you can do the tetra meshing. Now we have surface geometry, and it is a closed surface geometry. Therefore, you have to select the surface. Okay, click on this arrow and select the surface. Now, what type of 2D elements you want? You want either tri elements or R tri elements. That means right angle triangle elements or triangular elements. Okay, and 3D type. Which type of 3D elements you want? Here you have tetras, isolayers, split chords, and pyramids on chords. Okay, I want tetra elements. Now, what is the order of element? If it is a linear tetra element or it is a higher order tetra element. Okay, that is quadratic tetra element. Or if you want linear tetra element, you can select the first order. If you want quadratic tetra element, you select the second order. Okay, now I want first order. Now I will select the element size as a 10. Okay, now these two options are also important. That options I will explain later. Before that, I will show you your simple tetra meshing. Now I have selected all these options. I will select the surface. Now I will select the surface, this surface. I just click on one surface, it will select automatically all surfaces because it is a closed surface geometry. Okay, now I will click on mesh. Now it is creating the tetra elements. Here you can see here it has created the tetra elements. Okay, now how it is created the tetra elements, you can see here, and what is the shape of tetra element, I will show you. Now I will mask. I will first hide the geometry, and you can see here I will mask one element. See this, I am going to mask element, one element, mask, reverse. Now you can see here this is the single tetra element. You can see this is single tetra element. Okay, and it has 1, 2, 3, 4 nodes. If it is a quadratic tetra element, then it has 10 nodes. You can see here. I will change element type. Okay, I will change order change. I will set this element, and if I change to second order. Okay, before that I will show you nodes. Now geometry, nodes, temporal nodes I will select, and select this element. Select this element. You can see here 5 white dots are the nodes. White dots are nodes. That means you have added the nodes. If we click and add, that nodes are added to element. Already there are nodes, just we are making visible. Okay, now here these are the 4 nodes. Okay, for single tetra element, and it is a linear element. If I clear it, now if I convert that into quad element, quadratic tet element, now how I can do this? I will go to the 3D, and if I select the order change, and if I select change to second order, and if I select this element, and if I click on change order, its order will be changed. Okay, and now I will go to the add nodes, temporal nodes. Okay, And if I select all this, you can see here mid nodes are added at these locations. Okay, why? Because we have converted to the quadratic Tate element. Okay, now I will clear it. Now again I will convert that into linear element order change. Now I will set this to first order and say change order. You can see here now in geometry temporal nodes. Now if I select this element, then you can get nodes at the corners only, Okay, you can see here this is nodes at the corners only. Okay, now I will clear it. Now see, you can observe this as a Tate element. Now what I will do, I will go back to the unmask call. Now I will show you two options which I have not shown. For that purpose, I will delete all the elements. Now you can see this mesh, and if I on the geometry, if you observe this, okay, I will change the color, and you can see here. If you observe this geometry, it is, I will make it in line mode. I will change again the color. You observe this one here. This is the actual geometry and this is the element. That means your curved surface are not captured by your elements. You can see this gap. Now for capturing the curved surfaces, you have option, that is a use proximity and use curvature. Okay, now I will delete this elements displayed. Okay, now I will make it in surface mode. Now you can see here, if I go to the 3D tetra mesh, I have kept all these options as it is. Now I will use curvature. Now minimum element size is 2 and maximum element feature angle is 30. Feature angle means it is the angle between the normals of the elements, that is adjacent elements. Okay, and element size, average element size is 10. Okay, now if I do the meshing by this one, then you can see here, I will select this surface here. It is going to mesh. Now you can see here, if you observe the curvatures, here you will get the smaller elements. Okay, smaller elements, and on flat surfaces you will get the bigger elements. Again you can change this angle. If I, okay, I will reject this. If I make it 10 degree, okay, and if I mesh it, you can see here again you will get the smaller elements on the filleted edges. You can observe this one. Okay, do you agree with this? That means we can control the size of the elements on the curved surfaces by using this use curvature option, by entering the element minimum element size as an and feature angle. Okay, do you agree with this? And see here, if we consider the fillets are considered as a critical zones. So this use curvature option will help for creating the smaller elements on these curved surfaces or filleted surfaces. One more thing I want to tell you here. Here there is an extension in the solid geometry, Here there is an extension in the geometry. Now that means there is a sudden change in the geometry. So here that sudden change should be captured by the mesh. That means when there is a sudden change in the geometry, there is a stress concentration. Do you agree with this? So what we have to do, we have to reduce the size of the elements when there is a sudden change in the elements. Okay, now for that purpose, what I am going to do, I am going to delete this and I want to capture this sudden change. Okay. Now for capturing the sudden change, what I will do, I will go back to the tetra mesh. I am going to select this one. Now all these options I am keeping as it is. Only this use proximity I will make active. Use proximity I will make active. Okay. And same mesh. Okay. Now you can see here, it will take some time because it is going to create the smaller elements. Now you can see here you will get the smaller elements at this location, and size of the elements is going to increase towards the plane surfaces or flat surfaces. Okay, have you got this? Now it is a 12:20. I will stop here. If you have doubt, you can ask me.